Okay, before you start in on this assignment, you should have Ed Buzzle 6-7 done, the one on HL. If you haven't done it, you can do this. Just page 15 in the note packet. The first thing you have on page 15 in the note packet is what's the HL theorem. The HL theorem is a way of proving right triangles congruent. So what's the HL theorem? It's a way of proving right triangles are congruent. Basically, this is like side, 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 angle, angle, side, except it's only when we have right triangles. For a picture, we have to have a drawing of a right triangle, so we have to have a triangle. It's got to be a right angle, and that's going to come up even in proofs. We'll have to say this is a right angle, or we'll have to be told this is a right angle to do it. And then HL, well, HL is when we have one of the side or two of the sides congruent, but it doesn't have to be. What you're used to is side, angle, side, like this. But HL says if we have a side and one of the sides that makes the right angle, called a leg, and then the hypotenuse, which is the long slanty side that doesn't touch the right angle, if those two are congruent in a pair of triangles, then these triangles are congruent by HL. This is what HL looks like, a right triangle, and we have two sides, but it doesn't spell side, angle, side. In fact, if you wrote this out, this would actually be angle, side, side, which you're like, oh, but you said that doesn't work. Right, that only works in a right triangle. So it's basically angle, side, side with a right triangle. We have to have a right angle, and then it's one of the sides, the H. And H, by the way, in case you missed it, stands for hypotenuse. And L stands for leg. The hypotenuse is the long slanty side that doesn't touch the right angle, and the leg is either of the other two sides. All right? So that should help you to answer the questions right after. What's a leg? It's the short side that touches the right angle. And the hypotenuse is the long side that's not touching the right angle. For number 6, it only works in a right triangle. This only works in a right triangle. And on the bottom here, problem number 7, we're trying to identify which ones show HL. What we have here is the first picture. This is HL. Here's the checklist. Number 1, do they have right angles? Right there, right there. Those are both right angles. It's a right triangle. Second thing, is the hypotenuse the same in both? That's the long slanty side. In this case, it's 13 for both of them. So check. The H is the same. And the third thing is there's some other side the same, one of the legs. In this case, the 5 and the other 5 are congruent. So this is an example of HL. The second picture, also, this is an example of HL. Right triangles, check. Hypotenuse, it's the long slanty side, that one and that one, check. One of the other sides, bottom in both of these, check. So this one is HL. The bottom one down here, this one is not HL because we have side, angle, side instead. We have a right triangle, but the hypotenuse is not the same. Instead, we have side, angle, side in that one. And then our last picture, a little bit harder to tell, but you got to include this segment as being the same. And that side counts as the hypotenuse in both the triangles. That's the long slanty side. So the right triangle, check. The hypotenuse, check. One of the other sides, there and there, check. So that last one is HL. So 3 out of the 4 are examples of HL. Next, we're going to jump ahead to page 18 in the note packet. On page 18 in the note packet, 2 of the proofs are HL proofs. And we're going to tell you to skip the top one. Number 6, we're just going to pass on for now. Don't worry about that one. You can cross it off. And instead, we're going to do problem number 7 on the bottom. All right, problem number 7 is a proof. Do it the same way you do all the other ones. Take the given information and mark your picture to start. FG is perpendicular to EH. That means we got a right angle here and a right angle here. These are right angles. That's what perpendicular means. FE is congruent to FH. That means this side and this side are the same. And then finally, the thing we know is the center segment is congruent to itself. If you look in this picture, this is an example of HL because we have right triangles, check. We have the hypotenuse, check, and then one of the legs down there in the middle. So this is going to be an example of HL. All right, if we're going to write that into a proof, all right, we can see that the first part is given information, and we've already got the FE is congruent to FH down there. So the first one must be FG is perpendicular to EH. Then it says, and that's given. We have we have lines that make a perpendicular line. The second part, and this is in the end puzzle, we can now say that they're right triangles because that's the definition of a right triangle. When we have a perpendicular line or a 90-degree angle, that line almost always comes up in every HL proof that we have to say these are right triangles by the definition of a right triangle. That always comes up. Now, by the reflexive property, that was the center segment's congruent to itself, so that would be GF is congruent to GF, the center line congruent to itself. FE and FH are congruent because that was given to us. And then finally, these two triangles are congruent by HL. Okay, the last thing we're going to do, you should be able to get this paper from the substitute, which is a practice proof for the quiz on Friday. And the quiz will be like this, a simple proof, but nothing will be given. It's not fill in the blanks. You have to fill out the whole thing. But we do it the same way we always do our proofs, which is we start by marking our picture. So right off the bat, it says AB is congruent to AD right there. So we mark that in a picture. AB, AD. Those two segments are congruent. Second, it says BAC is congruent to DAC. Angle BAC, that's this one up here. It's congruent to angle DAC. That's this one right there. That is also given. So that'll be our second line of the proof. Then we also know that the center segment is congruent to itself. That's going to be by the reflexive property. And so finally, we can tell that these two triangles are congruent. This is an example of side, angle, side here. So all we got to do is take that same information and turn it into the written form of the proof. And here's what that same information looks like if you wrote it out as a proof. Tomorrow, Friday, in class we have a quiz. It basically looks like this sheet of paper, roughly the same type of proof, roughly the same level of difficulty.